All right, this is Module 4, Lesson 2 of Topic A. Today we're going to be able to determine if an expression is linear or nonlinear based on some mathematical guidelines and some rules. You'll know that you're successful when you can read a written statement, turn it into an expression, break that expression down, and figure out, is this linear or is it nonlinear? And you might be asking yourself, what does that mean and why do I need to know that? And we need to know what linear and nonlinear means for future lessons. We're going to be graphing these expressions and equations, and we can really knock out some of our answer options if we know, hey, this is not linear, this is not a line, or this is a line. It has to be a line so I can cross off B and C because those are not lines. Okay. Today we're going to review some vocabulary, and we're really going to talk about exponents when we review vocabulary because that's our rule today based on exponents. We're going to go over a discussion question and do some examples. So when I do these examples and talk about the discussion question, this is not in your provided notes. So this is something you need to take notes on yourself, okay? So have a piece of paper out, solve it with me, make sure you're jotting things down as you go. The exercises are what you will do on your own. And these exercises will be graded for participation today. So this is going to be graded. The closure and reflection, I'll have a lesson closure where you reflect on what we did. You'll be able to type something up in Google Classroom for other students to view. We'll review the main points of the lesson, and then you will do the exit ticket, which is also for a grade. So these are the three things that you're doing. These are the things where I'm just teaching. So keep that in mind as we go throughout this lesson, and let's go ahead and get started. All right, welcome to Lesson 2. This is all about linear and nonlinear expressions in X. Before we get started, I want to review some things about exponents with you because we will be using exponents today. So I'm just going to bring up a couple different exponents, and we're going to talk about what these mean. Okay, now anything raised to the 0th power, whether that's an exponent, whether that's a number, is always going to equal 1. We'll talk more about that later when we get into exponent work, but this is always going to be 1. If I have 57 to the 0th power, it equals 1. If I have 312.4 raised to the 0th power, it equals 1. If I have x to the 0th power, it equals 1. Now x to the first power just means that number by itself, okay, one time. So it just equals itself. Everything else is not going to be so simple. These are going to get a little bit more complicated. So x to the second power is x 2 times with a multiplication symbol in between. Okay, so it's just x to the second power is x times 2. Sorry, x times itself. That is probably the biggest misconception is that x to the second power is x times 2, and it's not. It's x times x. X to the third power will be x 3 times being multiplied. X times x times x. X to the fourth power will be x times x times x times x. And I imagine that you're getting the picture, okay? Now, our rule today when it comes to linear and non-linear expressions is that anything that has x to the 0th power or x to the first power is linear. Again, anything that is raised to that power is linear. It will make a line when we graph it, which we will eventually do down the road, okay? Anything that has an exponent of 2 or more, or a negative exponent, is going to be nonlinear. It is not going to form a line. So this is the rule that we're going to use today. We're going to do a little discussion right now and show you some examples. All right, so moving forward with our examples right here, we have a bunch of expressions, and again, expressions are statements that don't have an equal sign, written in these boxes below. There's 9 of them. We're going to determine if each one is linear or non-linear. So looking at this one right here, we have 5x plus 3. Now that x, does it have an exponent of 2, 3, or 4? No. Does it have an exponent of 1? Well, it doesn't look like it. But just like when we do a fraction and we say, okay, 5 is the same as 5 over 1, that 1's invisible. Whenever I have a number, say I have 5, that's the same thing as 5 to the first power, right? So this right here, this x, is actually being raised to the first power. It's just 1x, right? So this is linear. Going down to the one directly below it, I'm going to zoom in now. We have 4x squared minus 9. Now, right there, I see x squared, and I already know that that's going to be non-linear. So this is non-linear. Next, we have 11, parentheses open, x plus 2, parentheses closed. Now, some of these we're going to have to simplify a little bit in our minds. So if I were to use the distributive property and do 11 times x, I'd get 11x. 11 times 2, 22, and there is a plus sign in between. So I have 11x plus 22. There are no exponents there, which means this is linear. Hopefully you're getting the point as I'm going through these right now, okay? We have negative 8x plus 7/9 minus 3. Again, we're looking at that exponent. There's no exponent there, so that means it's automatically of 1. So it's to the first power, which means it is linear. Okay? Here we have 0.31x plus 7 minus 4.2x. Now we would be able to combine these because they're the same variable attached to that constant. But already, just looking at it, again, there are no exponents. We have negative 6 minus x plus 15 minus 9x. If I distributed this negative sign, this would become negative 6. Keep our minus sign. Negative times x, negative x. We could change this to a plus positive if we wanted to. We have plus 15 minus 9x. Now, throughout here, there are no exponents. So this is linear. Moving forward. Oh, already I see that x squared, so this is non-linear. Okay, already I see the x to the third power, even though it's x over 2 to the third power, it's still being raised to the third power. This is non-linear. And then we have 7 plus x to the negative fourth power plus 3x. Again, this is non-linear. The only exponents we are allowed to have for it to be linear are exponents of 0 or 1. Anything else, whether it's negative, positive, etc., it's going to be nonlinear. Okay, so this is pretty much our lesson today, is figuring out, is this linear, is this non-linear? Pretty straightforward. All right, here's our first example. We're not going to do all of this right here. We're just going to start here. The expression 57 minus x is linear. We know this because the x has no exponents attached, so this is linear. However, the expression 2x squared plus 9x plus 5 is not linear. The question here says, why is it not linear? And we should know just from the example or the discussion we had before this, is that the reason this is not linear is because of this right here. The x is being raised to the second power. The variable has an exponent other than 0 or 1. So I'm just going to explain that in writing. So the reason this expression is nonlinear is because the variable x is being raised to the second power. And our rule tells us that the only way an expression can be linear is if it's raised to the 0th power or the first power. And that is clearly the second power right there. All right, example 2, it says, let's examine the expression 4 plus 3x to the 5th power more deeply. To begin, we want to identify the terms of the expression. How many terms are there and why? So this is the first part of the question. It's asking, how many terms are there here? Now, if we think back, I believe you learned this in, honestly, 6th grade. We find the terms in an expression by finding all the plus or minus signs and drawing a line through them. Okay, this separates our terms. So here we have 1, 2 terms. So there are 2 terms. And these are 4 and 3x to the 5th power. The second part of this question says, how many terms comprise just constants and what are they? So the only term that is just a constant is this 4. Okay, so only one, and it's 4. Okay, next it says how many terms have coefficients and what are they? So coefficients are numbers that go in front of exponents. So obviously this term over here, 4, is not going to have a coefficient because there's no variable. Over here we do have a variable and we have a coefficient. So that number that's directly in front of the x is 3. So only one has a coefficient, and that coefficient is 3. Last question. It just says, is 4 plus 3x to the 5th power a linear or non-linear expression in x? Why or why not? So what they've asked us so far, these 3 questions, just helped us kind of break this down and look at it piece by piece. Okay, so we didn't really need to do all of this, but it helps you if you want to break it down further. So we know that this is not linear or non-linear because of this 5th power, right? Our variable is raised to the 5th power. And again, the only time an equation or an expression can be linear is if the exponent is raised to a 0 or the variable is raised to a 0 or a 1. And here we have it being raised to the 5th power, so it's non-linear. All right, example 3, it again has us breaking this down into the terms, seeing if we can simplify the expression first, and then determining if it's linear or non-linear. This is always good to do before we just answer straight off the bat if it's linear or non-linear, because sometimes exponents can cancel out. So if we maybe started with an exponent of 2, but somewhere down the road we divided by an exponent of 2, that would cancel it out and it would be linear. So we just want to break that down every single time. So it starts with saying, how many terms does the expression 7x plus 9 plus 6 plus 3 have? And again, we find our terms by drawing a line through each of the plus or minus signs and separating our equation. So you can see here that I have 1, 2, 3, 4 terms. And they are just that. They are it's a 7x, a 9, a 6, and a 3x. Okay? It goes on to say that this can be transformed. And the reason it can be transformed is because it's all plus signs. So anytime you have all plus signs, you can put it in any order you want, because order doesn't matter when you add. So if I had like 3 plus 4, that's the same as 4 plus 3. So I can reorder this if I want. And that's what they've done here. They reordered using the commutative property of addition, and they put the 7x and the 3x together and the 9 and the 6 together because those are like terms. They then combined them. Okay, so 7x's plus 3x's is 10x's, 9 plus 6 is 15. So this is what they have now, 10x plus 15. Then they're going to break this down again and say, how many terms does this have? It has 2 terms, 10x and a 15. Now, that we have this completely broken down, we're looking at our x, and we're going to ask ourselves, is this linear or non-linear? And if we're looking at this x, does it have an exponent? No, that means it's raised to the 1st power. It's only one of them. So this is linear because x is being raised to the 1st power. And again, it doesn't look like it is because it's just a 10x right here. But remember, 10x is the same as 10x to the 1st power because it's just 1x. All right, I skipped example 4 because it's pretty repetitive. Example 5 says, is 94 plus x plus 4x to the negative 6th power minus 2 a linear or non-linear expression in x? Why or why not? So we have 94 plus x plus 4x to the negative 6th power minus 2. Now, first thing we want to do is just break this down, make sure we can see all of our terms clearly. So I'm drawing a line through my plus and minus signs, and then I'm going to look at each of these terms. So if I look at 94, there's no variable there. Can't really talk about that. I look at this x. There is no exponent here. So this is good so far. So far we are good. It's linear. If I look at my third expression, I have x to the negative 6th power, or 4x to the negative 6th power. This does not fly when it comes to linear equations. Remember, we can only have an exponent of 0 or 1. And then our last term is a 2. That's fine because there's no variable. So because that one term had an exponent that was not a 0 or 1, this is nonlinear. Because x is being raised to the negative 6th power. And again, we can only have zeros or ones attached to those x's. All right, example 6. It says, is the expression x to the first power plus 9x minus 4 a linear expression in x? I'm going to break this down into my terms, draw a line through my plus and minus signs. And now I have 3 terms. Looking at this first one, x to the first power. Are we allowed to have x to the first power if it is a linear equation or expression? Yes, we can have to the first power. That's one of our rules. All right, we're looking at 9x right here. That x doesn't have an exponent, but we know that's the same as to the first power, right? So this one is also good. And then I look at my 4. My 4 has nothing attached to it. There's no variable, so we are also good here. So is this linear? Yes, this is linear. And then it says, what powers of x are acceptable in the definition of a linear expression in x? So what exponents could we have? We could have x to the 0th power or x to the first power. Those are both acceptable. Okay, now we're done with example 6. All right, here are your exercises for this lesson. You are not going to do all of them, and I'm going to show you a few before we are released to do your own practice work. So the ones that we are going to be doing are 1, 3, 5, 6, 7, 8, and 10. And I'm going to do a couple of these for you. Before we get into it, I just want to reiterate our rule for today. So, linear equations. Your linear equations have to have an exponent of 0 or 1. Okay? Nonlinear has an exponent other than 0 or 1. Okay? Now we haven't gotten to into this yet, but what if it's a negative exponent? So what if I have x to the negative first power? Would that be linear or nonlinear? Let's look at our rule. If it has an exponent of 0 or 1, it's linear. Is this a 0 or a 1? No, it's a negative 1. So this is automatically going to be non-linear. But I wanted to tell you that x to the negative first power is the same as 1 over x. Okay? So that's what that looks like. So if we ever see something like this, when we're simplifying these expressions down below, know that this is the same as this. And if it's this, x to the negative first power, anything to the negative first power, then it's going to be nonlinear. So keep in mind that if your exponent, or your, if your variable is on the bottom of a fraction, is, how do we say this? In the denominator, of a fraction, it may be nonlinear. Okay, there's a few times when the way that the expressions simplify cause it to be linear, and we'll get to those. But for the most part, if your variable is in the denominator, then it's nonlinear. All right, we're going to get started right into solving these. I'm going to do 2 of these for you before you go and do the rest that I've circled on your own. So I'm going to do number 3. And basically what we're doing with these questions, we are rewriting them as expressions, which is what we learned in lesson 1. And then we're doing what we learned in lesson 2 today, figuring out is this linear or nonlinear. So the first thing I'm going to do is turn this sentence into an expression. And I'm going to close read because that's what I learned to do in lesson 1. It says, multiply 6 and the reciprocal of the quotient of a number and 7. So I've read for the first time. I'm going to read again, and this time I'm going to annotate. Multiply, I'm multiplying 6. So one of the things I'm multiplying is 6. So I'm multiplying 6 and something else. I'm multiplying 6 and the reciprocal. Reciprocal means opposite. So when we talk about like fractions, if I had 1/2, the reciprocal would be 2/1. Okay? So I'm going to be doing this to whatever comes next. I'm going to do the reciprocal of this next part. The quotient, which means divide or fraction. The reciprocal of the quotient of a number and 7. So I know 7 is obviously 7, but I don't know what the number is. It doesn't tell me. So this is probably going to be my unknown variable. Okay, I've read for my second time, done some annotating. Now I'm going to read for my third time and define my unknown variable. Multiply 6 and the reciprocal of the quotient of a number and 7. Again, the only thing I'm unsure of here is this number. So my unknown variable is a number. I'm just going to call it n. So I'm going to call this n. All right? And I have done my close reading. I'm going to go ahead and just start writing this out. Make sure I have every part in it. It says multiply. So now I'm doing a multiplication problem. 6. So 6 and the reciprocal, so the opposite, or the flip of this thing that comes next. So this thing that comes next is the quotient of a number and 7. So I'm dividing a number and 7. So basically I'm just doing n divided by 7. Now to make this easier, I'm just going to rewrite it as a fraction. So it's going to be n over 7. Okay, so just to reiterate this, I'm going to start from the beginning. Multiply 6 and the reciprocal of n divided by 7. So what's the reciprocal of n divided by 7? 7 divided by n. So I have all my parts here. Just going to check to make sure. Multiply 6 and the reciprocal. I've done the reciprocal of this. A number, the quotient of a number in 7. So I have it all. 6 times 7 over n. So this is my expression that I'm working with. Okay, I've done the first part of my question. The second part is to figure out, is this linear or non-linear? So I'm looking at my variable n, and there doesn't seem to be an exponent, right? However, I told you about this before. If your variable is in the denominator, then it's non-linear, because this variable being in the denominator, this is the same as n to the negative 7th power. It's just written in a simplified way. So this whole expression is the same as saying 6 times n to the negative 7th power. These are the same thing. Okay? And now that we see it this way, the way I wrote it in red, you can tell that it is non-linear. Okay? Because our exponent is not a 0 or a 1. All right. The next one I'm going to do is, let's do number 6. Number 6. Got my close reading boxes ready. I'm going to turn this into an expression and then figure out, is this linear or non-linear? It says the cube of a positive number divided by the square of the same positive number. Read the first time. Now I'm going to annotate. The cube. This means something's being raised to the 3rd power of, so what are we cubing? We're cubing this positive number. It doesn't tell me what the positive number is. Divided by the square of the same positive number. So what I learned here is that these two things are the same number. Okay? It doesn't tell me what the number is though. Done with my second read. Now I need to define my unknown variable. When I read for the third time, it says the cube of a positive number divided by the square of the same positive number. Obviously, you can see where I have my question marks. That's what I don't know, is that positive number. I'm just going to call it, I'll just call it x. Okay? I've read 3 times. Now I'm going to get started on solving. So the cube of a positive number, we said that positive number is x. So I'm going to take x and I'm going to cube it. Divided by the square of the same positive number. So I'm going to be doing the square of the same positive number. And that's it. I have my expression, x cubed divided by x squared. Now when I look at this, I see that these are not raised to the 0th or the first power. So my automatic instinct is to say these are nonlinear. However, when we divide exponents, if we have the same base, which we do, it's an x both times, then when we divide, and we'll learn about this later as we progress towards like our unit on exponents, to simplify this, we just do 3 take away 2. You subtract. Okay, so x3 over x2 is the same thing as x to the first power. And from my rule at the top of this page, I know that x to the first power is permissible. This is linear. Okay, just doesn't look like it. Now your other ones that you have today are not going to be nearly as complicated. I did the complicated ones for you because you're not really familiar with exponent work yet. So the other ones are not going to be as confusing. You're going to do number 1, number 5, number 7, 8, and 9. So you have 5 questions to do on your own for these exercises. I'm going to pause this video right now. You're going to pause, and then you're going to come back and look at the answers. So please pause, go solve your exercises. All right, you should have solved number 1, 5, 7, 8, and 10. I'm going to start with number 1. It says the sum of a number and 4 times the number. You could have chosen different variables, but I have n plus 4n. The sum, adding a number n and 4 times the number. So when I add these two, this simplifies to 5n, and there is no exponent attached to that variable, so this is linear. Okay. Number 5, the square. So we're squaring the sum of 6 and a number. So if I take 6 plus n and I square it. So just to make this maybe make a little bit more sense to you, this is the same as saying 6 plus n times itself twice. Okay? You don't have to do it that way. I'm just letting you know for future reference. That's what that means. Okay? However, you know that parentheses mean to distribute, and if I were to distribute that square to the n into the 6, it would come out as 6 squared plus n squared. And if the n is being squared, that is nonlinear. Because we can only have an exponent of 0 or 1. Okay. Moving on to number 7, the sum of 4 consecutive numbers. So I'm adding 4 consecutive numbers. Doesn't tell me what the numbers are. I use the variable n. You could have used any variable. I have n plus 1 plus n plus 2 plus n plus 3. If I simplify this, I would have 4n plus 3, 4, 5, 6. Now even when I simplify this, you can see there is no exponent attached to this variable, so this is linear. Number 8, we have 4 being subtracted from the reciprocal of a number. It doesn't tell me the number, so I used n, and I did the reciprocal, so I flipped it upside down. I put a 1 on top. So 1n minus 4. Now remember about the type I told you, if your variable is in the denominator, then it's probably nonlinear. Our variable is in the denominator. And so this whole thing is the same as saying n to the negative first power. So this problem is the same as n to the negative first power minus 4. Okay, these are the same. And if I look at that n to the negative first power, I can see that this is nonlinear. Last one, number 10. The sum that shows how many pages Maria read if she read 45 pages of a book yesterday and 2/3 of the remaining pages today. So I have 45 plus 2/3 of the remaining pages, which I just said was p, because I don't know what that is. And if I look at my exponent, there is none. If I look at my variable, there's no exponent there. I can't combine these terms. I can't simplify this, so this is linear. Right? There's no exponent here. Hopefully this made sense to you. We're going to move on. All right, just to summarize this lesson before you move on to the exit ticket, we have linear and non-linear expressions. The difference between these two is what they look like when you graph them. And we'll do that later on in the year, but today we just wanted to figure out how we can tell the difference between a linear and a non-linear expression. Okay? Linear expressions can only have exponents that are 0 or 1. Okay? And if it's nonlinear, it has any other exponent. That could be negative, that could be 2, really close, right? Could be -1. So keep that in mind, that nonlinear have any other exponents. And the one thing I want you to remember before we move away from this is that if a number is, or a variable is beneath a 1 or whatever, it's under a fraction. I don't know why I'm having such a hard time saying this. If it's in the denominator of your fraction, this is the same thing as n to the -1st power. So this is nonlinear. Okay? All right, here's your exit ticket for today. You have 3 questions. These are the things you're doing for each question. You are doing these 2 things. You're turning your written sentence into an expression. That's what we did in lesson 1. And then you're going to determine, is this linear or nonlinear? And tell me why. The explanation is super simple, right? We went over it throughout this entire lesson. So as you do this, you're going to get points for a few things. You're going to get points for close reading. So please make sure you close read. You're going to get points for telling me your unknown variable for each of these. You're going to get points for writing the expression correctly. And you're going to get points for telling me if it's linear or nonlinear. And you're going to get points for telling me why. So for each of these, you have quite a few things to do. Close read. Define your unknown variable. Write the expression correctly. Tell me if it's linear or nonlinear. And then tell me why. Okay? So each one of these questions is worth 1, 2, 3, 4, 5 points, making the total exit ticket worth 15 points today. Okay? And that is it for this lesson. Make sure that you flip back if you need help. Rewatch the video lesson if you are struggling.